Welcome to Manimated AI. Alright, in the last video, we cracked the code behind the formula for eigenvalues and eigenvectors. Let's start by jogging our memory. How do we find eigenvalues of a square matrix? This was the main formula. For a square matrix A, a vector v is an eigenvector if it satisfies the equation a v equals lambda v. To find eigenvalues, we use the characteristic equation. Now to find eigenvectors. But knowing the formula isn't enough, we need to own it. So in this video, we're going to get hands-on and actually solve a few problems. By the end, you'll feel way more confident, maybe even a little bit like an eigenvalue ninja. So let's jump into our first example together. We'll master eigenvalues first, and then we'll unlock the steps for eigenvectors right after. We start by writing the characteristic equation. Determinant of a minus lambda, I equals 0. Now, we expand the terms from the determinant. Simplifying, this gives us a quadratic equation. We solve the quadratic using the quadratic formula. We simplify under the square root. And finally, we find the eigenvalues. Lambda equals 5 and 1. Now, let's solve for the eigenvector corresponding to lambda equals 5. We compute a minus 5i. That gives us this matrix. Setting up the system from this equation gives two equations. From the second equation, we see that x equals y. We can choose y equals 1, which gives x equals 1 as well. So the eigenvector for lambda equals 5 is 1, 1. Now, let's solve for the eigenvector corresponding to lambda equals 1. We compute a minus the identity matrix. That gives us this matrix. Setting up the system from this equation gives these equations. From the first equation, we see that x equals negative 3y. We can choose y equals 1, which gives x equals negative 3. So the eigenvector for lambda equals 1 is negative 3, 1. This is a diagonal matrix, so the eigenvalues are simply the diagonal elements. Start with the characteristic equation. Substitute the matrix A. Since this is diagonal, we multiply the diagonal terms. This gives us eigenvalues. Lambda 1 is 4, lambda 2 is 5, and lambda 3 is 6. Start with lambda equals 4. This system forces y and z to be 0, x is free. Choose x equal to 1. Now, for lambda equals 5, x and z must be 0, y is free. Set y equal to 1. Lastly, lambda equals 6. This time, x and y must be 0, and z is free. We pick z equals 1. And that's how you solve for eigenvalues and vectors eigenvectors. In this video, we worked through examples to gain a deeper, step-by-step understanding of how to solve them. Get ready. Next, we are going to learn the fastest way to find eigenvalues, see it in action, and master the method in minutes. Thank you for watching. Don't forget to like, share, and subscribe, and we will see you in the next episode. Stay tuned. This video is made by Astha Joshi. Keep learning, and I'll see you in the next video.